Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and we're going to be talking about some other interesting facts about the sun and what you can expect to observe over the course of the next 5 months, or 4 months, I guess, 4.5 months, as we get toward the first day of summer in June. As we've talked about before, there's an interesting things about the Earth. Number one, the Earth is tilted at an angle of about 23.5 degrees compared to the plane of the equator. Like if you have the Earth like this and the equator, goes right through the middle of it, the actual orbit of the Earth is tilted at 23.5 degrees. And this is why the sun has a different position in the sky in December than it does in June. Much different position. And then the other interesting thing is the fact that we are closer to the sun in January than we are in July. We've talked about how ironic that is, but it has more to do with the sun's angle of attack on us. In other words, in the wintertime, the sun is coming in at a very low angle. Radiation is not direct at all, and that has a tremendous effect, much more so than a 3 million mile difference from the Earth to the sun. And so when it becomes much higher in the sky, the radiation is much more direct, and as a result, we get hot in the summer, as you all know. All right, so let's go on ahead here, and I did want to give credit to one artist, Higher and Higher, which is what the sun's going to be doing over the next several months. So thanks, Jackie Wilson, for reminding me of that. All right, so we're going to talk about solar noon, okay? Solar noon is the time when the sun is at its highest position in the sky. Okay, and it would be tempting to think that it's at noon every day, right? It's not. In fact, most days it's not, and some days it's quite a bit different than noon. Rarely does it occur at noon, and it varies, of course, within a given time zone. If you're in the eastern part of a time zone, it's going to be very different than it is in the western part of the time zone. So I thought I would take the next 5 months, February, March, April, May, and June, all on the 28th, and talk about the times that these various things are occurring. Now, solar noon at Hatteras is 15 minutes after noon today. RDU is 27 minutes after noon, and out in Murphy, it's 48 minutes after noon, okay? The elevation angle doesn't vary that much because that is simply a function of what your latitude is, okay? And you can sort of almost figure this out by hand, that if you know that Raleigh is it's almost 36 degrees north latitude. And the fact that we know the sun gets to about 23.5 degrees north in the summertime, on the first day of summer, you just subtract your latitude or subtract the elevation angle of the sun, or the declination angle as we call it, the 23.5 degrees, where it's directly overhead, and then you look at the difference between that and your latitude, and that difference is about 12 to 13 degrees. So that means that the sun is 13 degrees shy of being directly overhead on the first day of summer. All right, so let's move on ahead now and take a look at March. And here, solar noon occurs at about 8 minutes after 1. Now, this takes into account daylight saving time, so it didn't jump just through physics that much. It was the fact that we turned the clock ahead an hour. RDU 119, or actually closer to 120, and Murphy at 141. So in Murphy, it's almost 2 hours after local noon that the sun is highest in the sky. The elevation angle, again, now we're getting higher, with most places within a little bit of 57 degrees above the horizon. Now, on April, solar noon occurs at 1 o'clock. Now, if you think about it, at Hatteras, standard time is an hour before that. So in this particular case, on the 28th of April, solar noon is about noon. It's just that we have daylight saving time, and so it ramps it up by an hour. RDU is at 112, Murphy at 133, and now the sun is about 68 degrees above the horizon, or just 22 degrees away from being directly overhead. By May, solar noon is just about noon standard time, or a 1 o'clock Eastern Daylight Time, 111 at RDU, 133 at Murphy, and the elevation angle now is up around 76 degrees, or only about, 14 degrees shy of being overhead. And finally, by June 28th, the elevation angle is close to its peak, 78 degrees at Hatteras, almost that at RDU, and a little over that at Murphy. And the solar noon now has started to deviate again away from actual noon, 106, 118, and 139. And again, that is Eastern Daylight Time, not Eastern Standard Time. So, I just thought you might find that interesting, that we sort of all assume that solar noon is the same thing as noon, and it's not. Sometimes it can vary quite a bit, and it varies a lot when we get into daylight saving time. The variances go up by an hour. And then, of course, the other thing is how high the sun is in the sky. That it's that shallow angle that we've got this time of year that makes it tough to warm up. It's like somebody, I think I used this analogy before. If you take a flashlight and shine it right in somebody's face, they're going to notice it if their eyes are open, all right? Even if they aren't, they might notice it. But if you put it at off to the side where it's sort of side swiping them from the side, they may not notice it at all, or if they do, it's going to be minimal. And so the fact that we are 3 million miles closer to the sun in January than we are in July, that effect is trumped enormously by the directness of the solar radiation that is coming in from the sun. All right, that's it for today. Bonus weather video number 1. The next one coming up on Friday afternoon, and we'll have another daily update for you coming up tomorrow. Have a great Tuesday evening, everybody, and we'll talk to you soon.